Let's talk distribution. I mean the way we multiply algebraic expressions, or at least the way we do it when it involves addition. The short explanation of distribution is that we want to multiply all the things from the first part by all the things from the second part, and then add them together. But that is really unclear and lacks any firm motivation for doing it. So let's look at an example of distribution in a familiar context. Let's multiply 237 times 153. A lot of older folks will say they learned how to do this by lining up the ones digit, then okay, great, but a lot of younger folks are now learning it like this. We see that these methods both get us to the same answer, but why would anyone teach kids the newer and obviously slower method? We do it so that what we're about to do makes more sense. Why not swap out the numbers we were just using for the polynomial multiplication 2x squared plus 3x plus 7 times x squared plus 5x plus 3. Akin to what we just did, we're going to use these as side lengths for a rectangle. We know the multiplication we're doing is the area of a rectangle, like this one. Then let's split up the rectangle along both sides to get 9 smaller rectangles. Our target area is the sum of all the smaller areas. That means we have to do each of these multiplications to fill out the full rectangle so that we can go and add all these pieces up. To add them up, we just match what the variables look like in each piece and group them accordingly. Okay, so we see geometrically how distribution works. Let's do a second example and drive this home. I'll include the rectangle to reinforce the idea, but my primary work will be only with the expression. The second example is 4x squared plus 2x minus 1 times 3x minus 7. We've seen several times that the process is just multiply each piece in the first by each piece in the second. So we do that systematically by taking care of each piece in the first completely before moving to the next. This gives us 12x cubed minus 22x squared minus 17x plus 7. Students who have seen this before are usually tempted to ask about the mnemonic FOIL. This acronym stands for first, outer, inner, last, and reminds students to follow that order when doing distribution. But it's super important to remember that FOIL is distribution, but distribution is much more than just FOIL.